Hi everyone, my name is Kevin Brodsky. I am a software engineer at ARM, and I worked on Morello and the Morello Linux kernel more specifically for several years. Today I would like to give you a short overview of the work we did there and the related ABI. So for Linux to support pure capability applications natively, we need to have a new kernel user ABI. That's because pure capability applications represent all pointers as capabilities, and therefore the kernel needs to handle those pointers being larger and a little bit special in a way. So that's the functional angle. There's also a security angle that the kernel needs to honor the capability properties and enforce them. Now there's two main aspects to that. One is input pointers that are provided to syscalls typically, and then output pointers created by the kernel, and typically that's pointers returned by syscalls like mmap. So in the case of input pointers, what is really important is that pointers that the applications provides to the kernel are propagated as capabilities in that ABI. And that means all the way to the point where they are used, for instance, to access user memory, copied to user here. In this way, we ensure that the kernel accesses user memory with the same privilege as whichever part of the application called made that syscall. In the case of output pointers, what really matters is that the pointer created as requested by the application here in the case of mmap has appropriate bounds matching the mapping here and appropriate permissions matching the mmap prot argument, and we also have a special permission to allow the caller to manipulate the mapping. So in the case of Morello Linux, we took the approach of representing user pointers specifically as capabilities using v__ capability annotation and leveraging the existing __ user annotation in Linux. At the same time, the kernel ABI remains unchanged, meaning that kernel pointers remain 64-bit. Now, an interesting challenge in Linux is that user pointers can be represented as something else than a pointer. So in the famous case of ioctl handlers, the unsigned long type is used. And there are many other cases like that. So for Morello Linux, we introduced new types to allow representing user pointers with a type that allows the capability to be stored in them and propagated untouched. Now coming back to more the output pointers aspect. So mmap, mremap, other similar syscalls, as I mentioned, create a capability with the right bounds, permissions, and so on. Now, when starting up the process, the kernel also needs to ensure that everything is appropriate for a pure capability application. So the stack is set up correctly, initial registers as well. Now, another big challenge for Morello Linux was to support standard ARM64 applications, so standard 64-bit ABI. And we achieved that by reusing the compat layer in Linux, which is normally used for 32-bit ABI, but here it's used for 64-bit ABI instead. So we had a number of challenges around mainly conversion between compat user pointer and native user pointer, which is mostly done correctly in Linux today, but there are some additional challenges when capabilities are involved, and also challenges with the fact that 32-bit is often assumed to be compat. So in short, the Morello Linux is a fork hosted on morelloproject.org, a GitLab instance. We have around 500 patches on top of mainline. And that includes support for Morello, the model architecture and pure capabilities of space with the hybrid approach I mentioned. And that's supported for a section of drivers. We can't build the entire kernel in that mode, but we support all the main drivers for the model board and fast model. And as I mentioned, 64-bit compat was really a major effort there. Now, separately, we also have a specification for the pure capability kernel user ABI that this kernel implements. That's hosted on the wiki page on modelproject.org also. It's been refined for over 3 years, in which we found many corner cases. So it is now fairly extensive with a lot of subtleties, especially around address space management, mmap, and so on, and also many other aspects. I hope this overview was useful. Thank you for your attention. And if you have any question, I'm very happy to answer any question via email or on CHERI CPU Slack. I left my details at the bottom of this page. Thank you.
I'll try and go quickly. Perfect. Okay, hi everybody, and thanks to Kevin for starting off the talk here. I'm just going to give a quick update on where we are with CHERI Linux within the CHERI Alliance and outside of it. So, where are we now? So, Kevin mentioned that the Morello Linux kernel was implemented as a hybrid kernel. What we've done for CHERI Alliance is actually do a pure capability kernel stack. We did start with the Morello code, so we used that as a basis and used all the work that they've done on the ABI, but progressed that to put pure capability mode because decision on whether that would be easier or the other would be easier, we sort of tended towards pure capability, getting full spatial memory CFD to start with. So our initial goals are obviously functionality first, get the thing working, and refine the security then. Where we are at the moment, well, we have 115,000 roughly lines of code changed. Now, compared to where we were when we first announced this about a year and a half ago, where we had 30,000 lines code changed, you can see the progress recently. Also, when we first initially did it, we had about 5% of the kernel converted or checked. Now we're up to almost an all yes config, which means all of the kernel is effectively configured as active. I would state that's compiling, but not necessarily all tested because we don't have access to all of the drivers. We do still have some key features disabled, which haven't been implemented yet. The sort of main ones of those would be eBPF, although we do have BPF functional, just not the JIT side or the compiled down side. And kernel modules is obviously a big bit lacking at the moment. We're testing the kernel now against LTP, extended for CHERI. At the moment, we're up to about 2/3 of the standard test passing, which has gone up appreciably in the last 6 months. So we're covering most of the major APIs now, which is good. We're also making very good progress on testing driver subsystems with real hardware. So we have things like USB up and running. We've got PCI Express, all of the devices attached to that. We have wired and wireless networking, audio graphics, all the stuff you'd expect from a normal Linux kernel, all running in pure cap. For the kernel security side, we're obviously restricting bounds as much as possible now. There are some areas, as Kevin mentioned, where we get past integer values, and then we have to put bounds on top of them. Still some of those, virtfizz being a good example. For the user space side, well, we're currently working with a Yocto-based Linux distribution. We're just working through increasing the capability of that to adding packages. And actually, that's been reasonably painless. I have to commend all the great work that CHERI BSD did in pushing patches upstream. We're finding that a lot of patches, or a lot of packages that we pull down into Yocto, require no change because the change has already been in there, which is great. Most of the modern packages as well require little modification. Anecdotally, C++ is slightly better than C, more because there's older C code in there, which sometimes causes problems. But modern C code we've had very little trouble with as well. So what's next? So what we're doing within the CHERI Alliance is creating a base kernel, base Linux distribution, really, that people can start playing with and extending. We have some decisions at the moment of whether to rebase our current 6.10 against 6.14, possibly. We've still got some implementation of legacy draft versions in there for the CHERI RISC-V side that we want to get rid of. We want to clean up the history a bit, obviously then make it public. We're going through this as quick as we can at the moment. We'll also push the Yocto system, or the Yocto build system up, so people can do a full pure cap Linux. And I should say the Yocto is pure cap as well. Everything on this Linux is pure cap. And there is a CHERI Alliance Linux working group as well, if you want to get involved. So next steps, and I can only comment on Codasip's input here on CHERI RISC-V side. What we're looking to do next is support both pure cap and non-pure cap in user space. And this is sort of a prerequisite for doing more complex Linux distributions where it would take a very long time to implement everything in pure cap mode. So it allows us to incrementally move to more secure Linux over time. Loadable module support is obviously high on our list, and compartmentalizing that as well. eBPF, as I mentioned as well, and security side, improving the bounds as well, put sub-object bound support in. On the user space, at the moment we're working on increase or improving the wireless support, but we're also going to start on a full Linux distribution. So we haven't decided whether to go for something like Ubuntu or an RPM-based one, but we will pick that in the near future and then start implementing a full Linux system on it. The other thing we're concentrating at the moment is improving the performance as well, because there is an appreciable performance gap between non-CHERI Linux and CHERI Linux. Simply because the CHERI Linux is designed to be functional, but we are missing some of the optimizations in there. To be able to do that, we have to start with adding profiling support in, so we can figure out where the problems are. We're looking at putting in the optimized string functions, so things like memcopy, copy to user in the kernel need to be optimized. We're looking at improving memory allocators, and we're doing a lot of work at the moment on improving the compiler itself, which will benefit not just Linux, but everything else. So improving the optimization passes in LLVM. And then we're looking at creating an FPGA platform. So we've been talking about this for quite a while, and we're going to try and get an FPGA platform out for people to work on. Unfortunately, it won't be as low cost as the low risk one, but hopefully it will make things a bit more accessible to everybody. Okay, thank you. Very quick overview.
2 minutes for questions, if you have. There must be some questions. That was a great talk.
Yes.
Do you think there's scope to use CHERI to make eBPF safer?
Yes, I very much, yes. eBPF, it's a jet engine, so I think we could certainly compartmentalize that off from where it is now. Yeah.
Is there any plans on upstreaming this work?
Yes. Okay, so asking about upstreaming it. So upstreaming is difficult for Linux at the moment because they tend to require hardware available and effectively commodity hardware that the kernel developers and testers can access. So that will limit the speed that we can upstream it. However, what we can do, what we are looking at doing is where the CHERI work has put in a general improvement, you know, more along the lines of the kernel janitor type work, cleaning up uses of unsigned longs versus pointer types and stuff like that, then we will try and push that up first. So not specifically CHERI, but general improvements. And then whenever we do get to the real silicon, then we can push up the rest.
One more question? Somebody? Anybody?
Similar question to the previous one. Did you find any bugs?
Did you find any bugs?
That's it. Nothing obvious yet, I will say. Yeah. It's hard to distinguish what we put in as bugs originally versus what might have been in there before. So, yeah.
Okay. Thank you very much. Thank you.